I want to go over the steps for installing the RT4 rotary table. So first of all, you need to turn off your controller and plug in the RT4 servo connector into the actual fourth axis output, which is the A axis, and the labels should match up on the back of the controller. At that point, you can turn on MotusCNC and home the machine, and it should detect your fourth axis. So the RT4 rotary table can be mounted on any position on the table. One thing to consider is how far back you place it, since you want to be careful that it's not going to run into the enclosure. So when you install it, it's a good practice to actually move the table as far to the left as possible, and then install your rotary table so you know that it's going to have clearance to whatever enclosure you have. The other thing I like to do is actually make sure the rotary table is square with the axis, kind of like squaring a vise. So I'll show you how I do that real quick. I just put an indicator on the back Z-axis column. And I just take the indicator and bring it up against the flange just slightly. Even though the RT4 has some keys, there's still some play that allows you to adjust things. So if you want to get the best precision, you want to make sure it's parallel with the A axis. So that's what this process is for here. I sweep back and forth, and then I'll move down while I still have clearance for the chuck. Now I'll actually get it so it touches the flange. And I'll just sweep it back and forth here. So that actually looks pretty good. I mean, I have very minimal. It's just under 5/10 thousandths that it's out, so that's perfectly fine for this setup. So, but if it's not, you're going to want to have these bolts loose and then just tap the RT4 a little bit back and forth, just like you would with a vise, to get it nice and parallel. So you want to mark the end face of the test bar you're going to machine. I just use a file and just make a little mark in the end like this. And this is supposed to be towards the rear of the y-axis, so the back side of the part, as you can see. This is so you don't lose track of what angle you started at. So when you mount the stock, you want it about 35 millimeters clear of the chuck jaws. So just gonna set that in there now. It's not critical as far as being exactly right. It's just a rough measurement. And this is going to keep basically this collet holder from running into our chuck. So we're only going to machine about 10 millimeters off the end of this here. So that should give us enough clearance relative to these chuck jaws to be able to complete the whole machining calibration routine. So once the machine is homed, you want to be able to show the rotary table. You can click here on the Show Rotaries button, and if you don't see anything, you're going to want to go here and then select the RT4 normal position. Press apply. Okay, so that's on the table now, but if you want to adjust the position of the rotary table, you can go back to here to the visualizer options and change this. For example, if I change this to 10, apply, it's going to move around, so you can change this. It's probably going to change against once we do the actual calibration a little bit, and then you might have to come back and offset this, but that's how you adjust the position of it, just visually. So now I want to go over to the actual routine that we're going to run. You can find the project, it depends, sometimes it's named differently, but you can find it also under calibration most of the time, and then it's like the align fourth axis or align rotary project. So here's this project. It's got some instructions, but basically this is going to be the diameter of what you're going to machine, which we're using a 3/4 inch piece of stock. This is going to be the final machined width, and this is your depth of cut per pass. This is the tool number you're going to use for actually cutting it. We're going to use tool number 1. I'm going to be using a 1/4 inch cutter, so I put in 0.25 times 25.4. And then this is going to be how deep down you go when you take the cut. And then, so that would be 3 times this, 3 times 0.25. Let's see, that's 3/4 of an inch. So it's going to go all the way down to the bottom of the part, so that seems fine. And this is how far back it's going to cut, so it's only going to cut back 6 millimeters. If you change this to be further back, you know, you have to be careful to push your stock out further because you don't want it to run into the chuck. This extra side allowance is basically if you're normally something you just use if you have a low torque spindle, because you don't want it accidentally taking a real deep chunk out, because you're just going to be aligning this by eye. So if you're off, however much you're off on one side, it's going to take that much off of the bar. So if you increase this, it just gives more clearance around the part to start with. And then you have your spindle speed here and your feed rate. Okay, so let's go back here now and rewind this program, and then you can press cycle start, and then it's still going to start giving you instructions. So jog the tool tip, the tool itself, down to the material. So you're going to want to jog it so it's just to the right of the rod. And then you're also going to want to make sure that in the Y direction it's centered. It's very important that you center it relatively well in the Y. And then bring it down in Z until it just is over the top of the stock. Okay, so that looks good. So now I'm going to press the cycle start button. And then basically it's going to give me some results. This is basically because it's setting the kinematics just based on this initial position that I chose. And we're going to have to press cycle start again for it to actually start the machining portion. So now the machining portion of the calibration is complete, and you have a coupon to measure. Okay, so the next step now is that you want to click on this update kinematics file. And so basically what we want to do is to have this section here is basically the actual measurements we make on our test piece from what we machine, and we're going to enter these values here and then run this file, and it's going to make all corrections to the kinematics. So basically this is the first flats in the marked direction. So if we haven't removed it, the marked direction should actually be where we expect. So it's going to be towards the back. So I don't need to make any changes there. And I am going to use just some calipers for this process, but you can also use micrometer if you want to be more accurate. So you got two options there, but for this I'm just going to use some calipers. So I'm going to measure the first flats, and that's 16 millimeters in diameter, or let's see here, 15.98. Measure that once more, 15.98. So I'm going to change this to 15.98. Now we're going to go to the next set of flats that is counterclockwise. So that's going to be like this. That's 15.81. Now make sure you don't measure too far back, because there's going to be rounds from the end mill back there. So measure towards the front and make sure you don't have any burrs that you're placing this on. So let me check once more here, 15.87. Okay, and now we're going to do one last measurement here, which is probably going to give that a try here. This measurement is 15.88. Okay, so now that I've got that done, I'm going to go here, rewind, and press cycle start. It's going to give me some numbers here based on what my deltas are. And then you want to press cycle start again to update the machine. And so at this point it will have saved the settings and updated the kinematics. So at this point you want to restart MotusCNC and the controller, but now you should have your axis nicely in the center. To shift the x-axis position, that's just based on where you want to run your part. So if you want to run your part that you're going to be running, you know, over here, you just move it to here and then click, you know, 0x via G54. Another thing to know basically with dealing with this is, like, if you're running your machine and you've been using a vise or something like that, so let's say you have a completely different G54 position down here. So if I zero these three axes here, I basically, you know, lose all, well, I'm not gonna, like, this should actually work. I'll just let it do that, so that's fine. Basically, you've been working over here on a vise and you've been zeroing the machine, so you lose reference to the center of the rotary table, but the kinematics are still in the background in the controller itself. So to get back to that, let's say you want to start using rotary table again after working on a job with the vise. Well, you just go to the offsets panel and you can say clear YZ rotation, and you can see now it brings back the true location. So now if I go back to my run screen, you can see that if I jog over in the Y, it's going to be correct when it's in the center again. So of course I'm not really straight on here, so go back a little bit here, but you get the idea. So basically you can use that clear YZ offsets to get back to the kinematic center of the rotary table. So that makes that pretty easy. And the y-axis and the z-axis as well, you know, should be correct too there. So you can see the z's right in the center, as long as you don't have some weird display issue here. But if you jog over to the part, you'll see that it's centered in Z now. So yeah, it definitely makes that easy, and make sure you use that clear YZ offsets, since that works pretty well. Okay, so that's should complete the process of calibrating your RT4 rotary table.